Hey there everyone, my name is Tux. I'm a programmer. I'm going to show you guys Rust 1.0. Today is Friday, May 15th. Rust Lang got its 1.0 production release today, so I thought I would go ahead and show you guys how to use it. It's a pretty cool programming language, so let's start off right here. Oh, and by the way, I'm going to be showing everybody this in Vim. I'm using Arch Linux. Kernel version 4.0.2. That's about it for everything about this. So let's go ahead and install Rust. Installing is really simple. We're just going to jump right into it. First step to using it, obviously it says to install. If you're on Linux or Mac, you can do this inside your terminal. I already have one opened up right here, so I can go ahead and do this. So I just simply take that, paste it in. And so it'll run it, and so you can continue running this right here. So it'll ask you if you want to do it, how you use just some stuff. The install will run under sudo, so it's going to ask you to enter your sudo password and things like that after everything's on there. If you're on Windows, you can get the 32-bit or the 64-bit installer. Obviously, if you have a 64-bit machine, you should probably use a 64-bit installer unless you were told. And it's pretty simple. You just simply run through it. So here it says Rust is ready to roll. Really nice and easy. That was that. That's really simple. It comes with Rust C, which is the compiler, the documentation, and Cargo, which is a really nifty tool, which we'll talk about in a little bit. So we'll talk about uninstalling it real quick. So if you don't want it anymore, you decide this isn't for you, and you're a lame-o and you just quit, you can go and use this shell script here that's automatically installed on your system, or you can just use the .msf file, or MSI file, sorry. If you're a Windows install, like I said, just download that. So alright, this is that. So check and see if it's installed. Now I'm probably going to get an issue here with a library. Yeah, see. Alright. So here I'm just trying to check the version of it. So the compiler here is giving me an error. It can't load the shared library. If you're running on something other than Debian, you may come into this problem here, unless you're special snowflake like me and have to run Arch. So this is really simple to fix. You can either edit your etc lib.so.conf file, or you can just ld config set that. So the way you do this is it's not working because it's not looking where Rust is. So and Rust installs the user local lib right here, as it says there. So you have to make sure this it loads it. So to load this, you have to run it as sudo and do ld config / user local lib, like that. And I already entered my sudo password, but otherwise it would ask you for it. Alright, so that should do it. Now we can check it again. And it runs. See, built 2015-05-14. Rust 1.0.0. Beautiful. So let's go into a few things on why you'd want to use Rust instead. Well, Rust is pretty much, I'm not going to say it's a C replacement, but it is a really nice language that is similar to C. It's very low level and it works exceptionally well. It's safe, meaning that it can manage memory and things like that. So if I'm just going to navigate to the website here, right here. So we see right here, Rust is a systems programming language that runs blazingly fast, prevents nearly all seg faults, and guarantees thread safety. I'm not going to get into the nitty-gritty of that because that goes really out of the scope of this first video here. But you can see it right here with the efficient C bindings. It makes it great for building an OS. Makes it great for perhaps building things that you don't want to fail. You can put ASM in line in it, or you can do C, and like it says here, you can do C bindings here. So guaranteed memory safety, so you're not going to have things like memory leaks, type inference. So you can see right here how it knows everything is here. It knows that is a string. It's pretty simple. And this is a goal of it, to have zero cost abstractions. So we're going to get into the nitty gritty of it right now. Let's go ahead and start it. So first we're going to set up a project. So let's make a directory. We're going to call this one our Hello World project. And then we'll cd into Hello World. So now we have an empty directory here. So Rust runs off of .rs files. So we're going to go ahead and make our main.rs file. Main.rs is the file you're going to put your main function in. So let's go ahead and do that. So what we're going to do, I'm going to open up in main.rs. I'm going to open this up in Vim. You can use your text editor, Notepad, or you can use an IDE, or you can use Nano, any of your favored text editor that you use to edit text. So just pick it up and run it. And this is on Linux, so if you're on a Windows system, you might have a little bit more difficulty to follow up, but I think Linux is better. So, and I'm not going to slow down for any Windows user, so you got to keep up. Maybe pause the video if you can't keep up. But anyway, here we go. So I'm going to go ahead and write in here my function. So we declare functions with fn. That's just how you declare it right there. So you see that right there. We have it fn. So we can do that. And so now we're going to write our main. So this is the function main. Main doesn't take any arguments, so we can do that. And then we can declare it with brackets, just like in C. I'm going to assume you're a little familiar with at least programming in general, so you know how to do a little bit of this. So now we're just going to make a simple hello world, as obviously chosen by our project name. So now we first start off with our print line. So it's simply done like this. Now this is the interesting thing, because in Rust functions if print line was a function, it would be like this, and we could just do world like that. So let's go ahead and see that right here. Should work, right? So I'm going to write it and quit, and now I'm going to run rust C. So to compile our stuff, we do rust C. It's very simple. So we just do rust C, similar to GCC or G++ if you used any of those on the command line. Then we'll just add our main file. So you see here it says unresolved name print line. Well, you know, you would assume it would work, but no. So this is the interesting thing. Print line isn't a function in Rust; it's a macro. And I'm not going to talk about macros because it's out of the scope of this little video. But of course, I'll show you what the issue is. And if you noticed, it didn't even generate a binary file for it. So we're just going to go in, and I'll change it. So to declare this as a macro, which you don't need to understand right now, but we'll declare this a macro, and you add that exclamation mark right after it. So this says this is a macro that's already been defined. So we declare it, print line, the macro, and then hello world. So I'm going to write and quit that, and then I'm going to go ahead and do rust C main rs. So when you see it, it says that and does that. And so now we have this binary file main. If you're on Windows, you'll see main.exe. And that's about it. So you're not going to see, and then you can just click it. You can click run or whatever, however you want to run it. But on Linux, it's just .main. So it's just main. So if you want to run it, simply just do /main like that. And there we go. Hello world. It's pretty unique. So I'm not going to go further into programming with this, but now I'm going to show you the other things that Rust comes with that are really great. So it comes with a tool called Cargo. So you have it there. It's Rust's package manager. Rust actually has a package manager similar to PIP in Python, except this one does a bit more for it. And I'm not sure how it handles the projects exceptionally well. However, this pretty much, it can build you a project you see here. So it compiles it. It removes the target directory, so you can remove your, you can clean it up and just remove all the useless stuff. So it can even build documentation for you. It creates a new project, which I'll show you. It builds it and runs it. If you have tests, it'll run it, and this will do benchmarks. And this will even update the dependencies you have listed in the cargo.lock file, which we'll go through it now. So let's go ahead and so let's understand the structure of everything a bit. So first we're going to go ahead and let's just delete our binary file there. So it's as if we never compiled it. So we're going to go ahead and create a source directory. So now we have source. Source is where all the similar Rust source files go. It's not where your library files go. This is where your source files go. If you know anything about C and C++, you know something similar between your headers and your source files. So we put our source files here. So let's go ahead and move our main to source. Alright, so we moved main into source, so we can do this. So check it out. See, now you have that in there. So in this directory, our parent directory for this, which is our root project directory, hello world. This is where you put things like readmes or licenses, things like that. So we're going to go ahead and build our cargo file. Our cargo file is interesting because cargo will allow you to just have a really simple, easy to build way of running it, executing it, and building all at the same time. So we're going to go ahead and we're going to create the cargo config file. Its extension is .toml, which is it's a config writing language or extension. So we can do. I'm just going to open it up. So let's actually create it first, so you can see that steps there. So cargo.toml, like that. So you see it there, cargo.toml. I'll open it up, cargo. So now you write it inside. You got to declare, so we got to declare, it's similar to INI if you've ever seen it. If you know what INI is and you've ever seen anything like that. But so we're going to go ahead and write the declaration of the package. So what we're going to do is declare that this is a package. And you do that by just doing this in square brackets, package. Now we declare the name of it. So let's do hello world. Then version, so it's a 0.1.0. And then we'll declare our authors. The authors is you can have multiple of them, but you can do I'll just do tux, and you can put your email addresses to the Git standard, but you can do this and maybe another one if you want. But so I'm just going to put my name right there. So I'm going to write this, and that's our. So let's just do it real quick again, just so you can look at it. So as you see there, we declare our package, and here we have our name of the project, the version of it, and the authors. So that's that. That's really simple. TOML, just to tell you about it, it's a really minimal file format for config files. It's easy to read. If you want to get on technical terms, it's supposed to be used to design just to use with a hash table. I'm not going to go into that, but that's about it. So now that we have cargo already, our cargo file here, we can run cargo build, and that's really simple. We just do cargo build. This will compile it and run it. So we do cargo that build. So you saw it compiled. I'm sorry you didn't run it, but it'll build it here. And so now we have. Well, I'll show you the little directory. So now we got a new file, target. Target contains numerous things. I'm not going to go into depth about what target contains, so let's just go in it. Target. So now we got debug. So this is the versions we have. If you wanted to release something in release, which I will show later, so this is our debug version on it. So similar to a development version. So now we have debug we have examples of things in there, which I'll show you. They don't contain anything, but it allows us to show things in there. Show what's in there, so we can add things in there if we're working on various things. So we can have build things, native stuff in there. Nothing in there because it's just a very simple program. But so let's run our binary. It works the same way, just like that /. So back out. So now we notice we have a cargo.log file, so that runs that. So you can also, let's say we also just, instead of navigating into target and going to the debug and running that from there, you can do cargo run. And so it runs it. It says that it's running, and then just runs it. That's how simple it is. It's a really, really easy thing. It's similar to I almost want to say make files and things like that, but not entirely. But that's that. It's really, really simple. And so the next thing we'll notice is that it created this file, cargo.log. So let's go in there. Alright, so this pretty much, this is used to keep, it's used to keep track of dependencies in the application. We don't have any, so it's a really small file. You really don't ever need to touch this. You won't ever have to go in it because this is something for cargo to use by itself. It always updates it for you, so you don't need to even worry about it. So yeah, that's really it. It's really simple. So now we're going to go through it. So we're going to do the same thing we just did, except cargo will do it for us. So notice I have hello world right here. So I'm just going to delete that entire directory there. I don't need that anymore. Cargo, in fact, does it for me. So I do cargo new, declaring that we're going to do a new project, and we can do hello world. And here's the next flag we gotta use. We gotta use --bin. This means it runs as a binary. It executes a binary file, and that's what we're gonna compile to. If we were to make a library, we'd leave this off just like that. But we are going to make a binary. We're gonna run it. So we're gonna go ahead and run this command and just build it. So we got the same thing. So we'll go to hello world now. We got the same exact thing, except we don't have that binary or the source. So we go to source, and there's our main right there. Everything is in there. And so, and we go back out. Right there. So it's the same exact thing I wrote before. Just like that. It's really, really simple. It does it all for you. So let's go back in here. Let's see what is in main. And we see it says hello world. This is not because we named the program hello world. This is just a basic way it generates code to say this is where you write your code. So there's no need to really worry about this. You can just delete this line altogether and you know, rewrite it and do whatever you want in it. But it just does this for you. So it's no big deal. No need to worry about it. So here we're just gonna back out. So notice how we don't have that binary. If I do cargo run, it compiles it for me. So if you do cargo run without it even compiled, it notices the file changed. So it will run it, it will compile it and run it for you. So you see it's doing the same exact thing as the program we wrote before it. So I'm also going to show you something. So if we go into our target directory, you see we have debug. So it's the same exact thing as I showed you. Same exact thing I showed you before, except we have our binary here. So you can still run it the same way, but we don't need to do that. We can just use cargo run. So here is another interesting thing. So when you're done, let's say you want to push to production. You have a new release and it's ready to release. So you can do cargo build and then do release. And so that builds you into our release directory. So now we have this release one here. So we got release here, and we have everything you need to know about it right here. So it's just the same exact thing, except you just have different. You can use it. It's just a way of organizing stuff. Some ways run it different, but yeah, there's nothing in it. It's just the same thing, and the binary does the same exact thing. But when you do the -- release flag, there is one unique difference. Just the normal way doesn't optimize anything. However, release -- release does optimize things. So it's similar as using the optimize flag on GCC or G++. But yeah, so it optimizes it a bit and lets it run faster. However, there's not much to optimize in a Hello World program. But yeah, that's it. That's our little intro to Rust. I might make another video. I don't know. But yeah, and it's really, really simple. Yeah, I think, and I really enjoy it, and I really enjoy working with it. So, thank you guys for watching. Thanks a lot.